we are going to look at how to find reverse form of compass bearing. So there are two questions on the screen. The first on the left, written in black: if the bearing of A from B is south 20 degrees west, find the bearing of B from A. And this one is: if the bearing of Q from P is north 25 degrees west, find the bearing of P from Q. Let's tackle the first one. Sorry for that interruption, I got a call. If the bearing of A from B is south 20 degrees west, find the bearing of B from A. The second one is: the bearing of Q from P is north 25 degrees west, find the bearing of P from Q. Now let's sketch the first one. We are going to tackle the first question. South 20 degrees west. South 20 degrees west. It means from the South Pole, I'll turn 20 degrees towards the west. And this is my direction. I need to close this position with another cardinal point. Name the relative position. Position B and A. Let's place them at the appropriate position. The angle will be located at B. So this is our B, south 20 degrees west. Let me indicate the 20 degrees. In bearing problems, if we sketch the diagram without putting all these relevant details on the diagram, you'll be penalized. So always put the relevant details, the angles, the relative positions, the points. You have to label all these things. They are very important in order not to be penalized. Try as much as possible to indicate all of them. Now we are looking for the bearing of B from A. Now we are going to find the angle at A in terms of compass bearing. So this line at A is in the first quadrant here. So the angle should be measured from the North Pole towards the east. So North Pole, what would be the turn from the North Pole towards the east up to this line? So we need to calculate the value of this angle here, the value of this turn from the North Pole up to this line. We are going to use the properties of parallel lines. This line is parallel to this line. It makes this shape a Z. Hence the angle here, alternative the angle here. So the angle over there too will be 20 degrees. So let me put that there quickly. 20 degrees. So in that instant, the bearing of B from A is, in terms of compass, north 20 degrees east. North 20 degrees east. Sorry, north 20 degrees east. At the north, I turn 20 degrees towards the east. Now let's look at the second question. If the bearing of Q from P is north 25 degrees west, find the bearing of P from Q. We'll first draw our first point where the angle will be located, 25 degrees, north 25 degrees. Remember, this position will be called P. because that is where the angle will be located from P. Now at P, from the North Pole, we'll turn 25 degrees towards the west. 25 degrees towards the west. Then we go up, then reach point Q. So here's point Q. Here's point Q. Point Q. Let me name it. It's called Q. Point Q. Okay. Place my arrows on top of my line. Very relevant. Then I indicate the value of the angle. It's also necessary. 25 degrees. So we need to find the turn. To find the bearing of P from Q, we're going to find the angle here. At Q, at the South Pole, how many degrees should we turn towards the east? At the South Pole, how many degrees should we turn towards the east before we can walk down to P? And you can see that this forms an alternative angle because the line here and the line here are parallel. It makes this line a transversal line. So this angle is alternating to this angle. The 25 degrees here can be projected here. So that portion can also be classified as 25 degrees. In that instant, we will say the bearing of P from Q is south 25 degrees east. South 25 degrees east. In compass bearing, find the reverse form is not difficult. Let's look at what is happening here. I'm going to copy this and come and put it under this one. Copy this, put it under this one. Sorry. Let's copy this and put it under this one. Then we'll do some comparison. You can see from here that in reverse form the angle maintains, only that the south becomes north and the west becomes east. Similarly, here the angles maintain, so and the north becomes south and the west becomes east. So if it is an objective question, you don't need to draw diagrams. For example, if I have south 80 degrees west, then automatically it reverse form, you just change the south to north, the angle maintains, and then the west becomes east. It's very simple. It's very simple. Now we have learned the basics of bearing. We are now entering the stage that is more interesting: distant bearing problems. It is more interesting. We'll now go into that instance. But before then, there are certain things I would like us to look at before we enter into distant bearing problems. Now, there are certain terminologies that when it comes to distant bearing problems you might come across them. Let me just discuss that one briefly. Sometimes you will hear something like A is due north, let me put the S there, is due north of P. Q is due west of R, or something is due south of something, blah 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 blah. What does it mean? When you say A is due north of P, this is how it means. It means if this is my relative position P if this is my P is here. Remember, when I say P is here, doesn't mean here. The exact position of P is here, but we can place it anywhere closer. Placing it on this point to make the diagram clumsy. If A is due north of P, it implies I can get my A by, let me do that. Well, I can get my A by extending the north pole of P. So the position of A will be somewhere here. A. Then we have another one. Q is due west of R. Q is due west of R. If this position is my R, I can get the position Q by extending the western line of R. So this will be it. Extending the western line of R. So Q can be located somewhere here. Call here Q. If it was due south, I would have extended this portion. If it were due west, east or east, I would have extended this portion. So take note of this term as the lesson progresses. You might come, or in certain books, in your textbooks, or in certain questions, past questions, you might come across some of these things. So take note of them. Take note of them. Now, before we do the distant bearing problems, we shall look at what is known as the Pythagoras theorem. You did Pythagoras theorem when you were at the GSS. We'll go through. First and foremost, Pythagoras theorem deals with it is the theory is based on a right angle triangle. It's based on a right angle triangle. This is a right angle triangle. In case you don't know, it is called a right angle triangle because one angle is exactly 90 degrees, and the line facing the right angle is always called the hypotenuse, and it's always the highest side, the longest side of the triangle. So the Pythagoras theorem is basically based on the right angle triangle. I want to emphasize that you don't apply Pythagoras theorem on any other triangle apart from the right angle triangle. Now, what does the Pythagoras theorem say? This is called the hypotenuse because it's the longest side. Let's call this place B and call this place A. According to the Pythagoras theorem, the square of A added to the square of B will be exactly the same thing as the square of H, the hypotenuse square. The square of the hypotenuse is always equal to the sum of the squares of the other sides. Take note of that. The sum of the squares of the other two sides is always the same thing as the square of the hypotenuse. Be careful, because I want to emphasize again that the Pythagoras theorem is only based on right angle triangle. A triangle with one angle exactly 90 degrees. If you don't see the right angle triangle, do not apply this concept. This concept is not applicable for any other triangle apart from the right angle triangle. We shall now look at the basic trig ratios the basic trig ratios. Basically, there are three ratios. The basic ratios are three, and these are the sine, and this is the short form. The short form is SIN, so pronounced as sine, not sin. Sine. Short form is SIN, still pronounced as sine. Cosine, also pronounced as cos. The short form is cos. Then the tangent, the short form is tan. These are the basic trig ratios. The basic trig ratios are also based on right angle triangle. So you can apply the basic trig ratios on any other triangle. Yes. By extension, the sine, cosine, and tangent can be applied on any, especially the sine and cosine, on any triangle. But the basic trig ratios, the sine, cosine, and tangent, are basically based on the right angle triangle. So we'll look at that. First and foremost, let's look at sine. Sine. When you talk about ratio is just a fraction. So now let us look at what does this fraction talks about. I'll come to sketch a right angle triangle. Any right angle triangle has a hypotenuse which always faces the 90 degrees angle, and this is my 90 degrees angle, and the hypotenuse is always the longer side and always faces the 90 degrees angle. So this is my hypotenuse. In trigonometry, after you have identified the two angles, identify the hypotenuse, the two other sides have gotten names. One can be called an adjacent and the other opposite. Let me write this name down. Adjacent and opposite. Adjacent and opposite. In fact, this line can be adjacent, it can still be classified as opposite. This line can be classified as adjacent, it can still be classified as opposite. Please, in trigonometry, most students make this mistake. It is only the hypotenuse that has a fixed name. The other two sides get their names based on the acute angle you are going to refer. So for instance, I am going to place an angle A here, or let me call it angle X. Angle X, and then place another angle here, angle Y. Good. Based on the side that you are referring to, the angle that you are referring to, it would determine the name you should give to this side or that side. But before then, I will I want us to look at the meaning of the words adjacent and opposite. We are going to look at the meaning of these words, adjacent and opposite. I'll just use Microsoft Word and look at the synonyms of these words. Let's look at the synonyms. These are some of the synonyms of the word adjacent. Head to head, end to end, together, next to, in line, neighboring, contiguous, nearby. These are some of the synonyms. So let's go back to our diagram. If I am referring to X, which of these lines, this and that, will you classify as a line next to, nearby, beside, end to end. Which of these two lines will give those classification that the line is near to, end to end to, beside to the letter X? Which of these lines? Let me call the lines A and B. These lines A and B. Which of them will you say is next to? It's end to end. Let's go back and look at some of the synonyms. Adjacent synonyms: head to head, end to end, together, next to, in line, neighboring, contiguous, nearby. I mean, which of these lines will you classify? Obviously, we'll say A is nearby, is end to end, is beside the letter X. So if I'm referring to X, then my A will be called adjacent. So in terms of the angle X, A is the adjacent. Let's look at the meaning of opposite. The synonym of opposite: conflicting, contradicting, different, reverse, contrary, oppose, matching. Let's look at others. Far. This antonyms, okay. Okay, I wanted to see whether I will get a word like face to face. Opposite means something that face another thing. I'm living opposite to your house. That means my house is directly facing your house. So it means that if this line is adjacent to X, then obviously B will be opposite, facing X. But when I'm referring to this angle Y, B will no longer be opposite, because B is not opposite to Y. B is adjacent to Y, because adjacent means beside, nearer, a neighbor, whereas A becomes opposite to the adjacent, opposite to the angle Y. Take note of that. Take note of that. So the angles, the sides of the right angle triangle are not static. Their names are based on the acute angles we are referring to. The sine of any angle is a ratio between the opposite and the hypotenuse. Sine theta is equal to opposite over hypotenuse. In that regard, sine x is equal to opposite, which is the B, over the hypotenuse, which is h. Sine x is equal to opposite, which is the B, over the hypotenuse, which is the h. If I'm looking for the ratio for sine y will be equal to opposite to the y is a over the hypotenuse, which is h. So take note of that. The formula for sine theta is always opposite over hypotenuse, opposite over hypotenuse, and that of sine and so with regards to y diagram, if I'm referring to sine x, this is the opposite, so it will be b over h. If I'm referring to y, sine y will be a over h. Sine y is equal to a over h. Take note of that. Now let's move on to the next trig ratio. The next trig ratio. Next trig ratio. Cos. We are going to look at cos, cosine. The part of the right angle triangle, the names of the parts is the same thing as we have discussed when we were talking about sine. There's always a hypotenuse with a fixed name. Then we have one side of opposite, one side of adjacent, depending on the angle that you are talking about. x. If I'm referring to x, is the opposite, there's the adjacent. If I'm referring to y, there's the opposite, there's the adjacent. Take note of that. The formula for cos is adjacent over hypotenuse. Adjacent over hypotenuse. In that case, if I'm looking for cos x will be equal to my adjacent is m over my hypotenuse h. If I'm looking for cos y will be equal to, where's the equal sign, will be equal to the adjacent to y. The adjacent to y is n over the fixed part, which is the hypotenuse. So take note of that. We shall now go to tan. The formula for tan theta is always equal to the opposite side over the adjacent side. Hope you are writing them down. The opposite side over the adjacent side. So with this diagram, tan x, the tan of the angle x will be equal to the opposite to x is n and the adjacent is m. And then if I'm referring to tan y, the opposite to the angle y is m over the adjacent n over the adjacent n. Take note of that. I hope you have heard the common acronym that people have been saying. So twa. It summarizes all the trig ratios. So twa. It means with the sine theta is equal to opposite over hypotenuse. Cos theta is equal to adjacent over hypotenuse. And tan theta is equal to opposite over adjacent. So you take note of this acronym. SOHCAHTOA. Every mathematics student knows SOHCAHTOA. If you have not heard it before, then put it in your mind. It's a common acronym, and you use this not only in trigonometry, you use it in a lot of calculations. So put that in mind when it comes to mensuration and other topics. Sometimes even vectors, SOHCAHTOA will come. So take note of these formulas. SOHCAHTOA. The so means sine theta is equal to opposite over hypotenuse. Ka means cos theta is equal to adjacent over hypotenuse. And toa means tan theta is equal to opposite over what? Adjacent. Remember that in a right angle triangle, it is only the hypotenuse that is fixed. The adjacent and the opposite are named based on the acute angle we are referring to. But as for the opposite, it's always, as for the hypotenuse, it is always hypotenuse. With this little background, basic knowledge on trigonometry ratios, we're not doing trigonometry, so we will not be doing much into those things. So I will just go to the distance bearing problems, and when the need arises that I have to apply some of these trig ratios, I'll do mention them again. so that you get conversant and get used to them.